Okay, the stream should have started. Let me know if it's working. Don't want to
I
like.
need to like see if I can get something really fancy.
So any Ruby programmers in the house?
I did stuff in Ruby at one point, but it was more like Ruby on Rails, so it's kind of like,
Weird DSL Ruby.
yeah, not really Ruby. It's just more of a gem. Well, the Ruby on Rails, the Rails is like a gem that you install for Ruby, so you really don't really use Ruby so much.
I'm not really a terribly big fan of the way Ruby does DSLs compared to like some other languages.
Yeah. I actually really happen to like the way Ruby does scoping,
I don't particularly like its scoping rule either.
like for imperative style languages. Like, braces are too small, white space is too stupid, do end is way better.
Yeah, I do like that more than I like.
It's loud enough when you're talking there. So.
Awesome. Awesome.
We can't hear anyone else.
I know Jay wanted to be here, so
He's got it on his monitor.
I guess he's dead or something. So I'll take a moment for Jay, then we'll get started.
You say that and we find out that he was actually the by us.
Oh shit.
No.
Jay wanted to be here, Josh. Whatever.
Oh man, I like their logo.
Get it?
No, I don't.
It's a drop. Okay, so no one has done Ruby except Josh and
I've done a little bit.
you.
I haven't done like a lot of Ruby.
But like you know what it looks
I've never
like.
actually made anything useful.
I had to.
No one's ever made anything
I
useful
had to
in
learn.
Ruby.
I had to learn Ruby for that MailChimp job, and I used it a little
Oh,
bit.
yeah.
Then we just switched over to Python.
just one bad decision after another, huh, Josh?
I'm
kidding.
There are certain parts of Python I like more than Ruby, and vice versa.
Let's have a flame war. There's a section for that here in the slides, so we'll wait till we get that. Every time. I don't know. This talk is not opinionated except for this one part, and you'll be able to tell when that is. So. There's no water.
I can ask when they do it.
All right.
Without this water.
Okay. Okay, I'll get started. Hey everyone, welcome to Elixir, the talk 2017. No one's familiar with it? Good. That means it'll be new to everyone. Announcements beforehand is anyone have any Linux news actually?
I saw something.
Alright, think about it. Then
Let's go hack.
no, just get off. The next thing is that
30 Cow Times 2 was released. It's now 2 30 cows.
I asked Grey Hat if they want to do a collab together, like with for their CTF, and they just got back to me and they were like, yeah, okay, let's do it. So I wrote some flags a while back and we tried to do that ourselves. And so I'll submit those to them. If anyone has any other challenges, like Linux challenges that they want to submit, email me. And then, a lot of people will have presents at Grey Hat's next CTF, which is April Fool's Day. Maybe they're lying to me and saying, this is a good day to show up. It's April Fool's.
Oh, I turned it off.
Yeah. So that's a new thing. On to your question, Colin, I put an order in. Jesus. I put an order in for the touchscreen.
Oh, you ordered it?
Yeah. So,
Oh, are we doing that? Are we still building the
Yeah.
The budget, like this year,
Do we even have a budget anymore?
asked all the CSU orgs works. It took kind of a while to get like budget through this semester. Everyone's nice now, and we'll pick that back up. But next week is spring break. Spring break. What?
You're not loving
Okay, I bought Girl Scout cookies from Troy to sweeten them up before like I made the pitch, and it worked. So, you know. Okay, let's get to it. Elixir. What is Elixir? Well, to first know what Elixir is, you first have to learn some history and to know what Erlang is. So, this. Oh shit. Erlang the movie.
Oh God, you didn't copy the thing that. This is not the thing that Jay put up, is it?
What thing that Jay put up?
Jay put up Erlang the movie too.
Erlang, the TV show, The Quest for More Money.
Yeah, if you just have one of them on VGA.
Is this gonna work? Yeah, I forgot about this. Okay. Oh, it's kind of working.
How programming languages have several advantages
Oh, wait.
over traditional. For example, programmers in such languages.
Anyway, we're not by any means watching this whole thing. It's way too long. But like, this was a promo video for Erlang.
How programming languages have several advantages over traditional.
It's very old.
Programmers in such languages are considerably shorter than equivalent programs in comparative languages. Here, for example, is a program in C. Here is an equivalent program in R.
So obviously, a long time ago, before computers maybe even existed, I don't know, Erlang came on the scene because it wanted to be a declarative programming language. It was made by Ericsson. They're actually the career first. If you go and ask them about it, they'll be like, wow, you're really cool since you know about this weird shit we did a long time ago. Maybe we can get you like a phone or something. I don't know what they do now. It's probably... Erlang is still being developed. It's still being used, actually, a lot. It came on, and it really made some huge improvements and changes in concurrency. And it's basically, this is the actor model to like the fullest extent, like on steroids. And so you can see it's like kind of functional, basically. It's like, this doesn't give you a lot of the syntax. But that's what Erlang does. Or is. And here, and then they just like call each other on the phone a lot. Using Erlang. So why was the system developed? It was developed to help the telecom, like phone communications through Ericsson. Basically, if you have a phone communication scheme, you make like a connection to another phone, and you want to be able to talk. And if something went wrong with that connection, if you had a bug in some code and that connection died, you didn't want everyone else's phones to die as well. So that's the like motivation behind it. They are making a call,
System works.
checking if it works.
I apologize for like all the beats.
It's okay. It's beeps.
Mike. Hello, Jared. System working? Okay, fine. Right.
So you just saw it there. That's proof that Erlang works. Presentation over. We don't have to talk about Erlang anymore. So yeah, like totally works. If you want to learn more about Erlang, which maybe I don't know why you would if you came to this presentation, but there's a book called "Learn You Some Erlang for Great Good." It's kind of like the Haskell one, and that's where this image is from. I'm doing all my image attributions post making the slides this time because I forgot about them. But go check that book out. So what is Elixir and why is it different from Erlang? So Elixir came after Erlang, and it is just based on the same virtual machine. So Erlang's VM is called Beam. It's the same thing as like Scala in Java, Clojure in Java, a lot of things in Java. Anyone else know a Java thing?
What?
On the JVM, but not Clojure or Scala?
everything to compile to like,
JPython,
Everything.
but doesn't have a kill.
Jython, Druby, all great projects. Okay, so what's different? Oops. Erlang has the pipeline operator, and that's it. So why is it different over other languages, right? One,
So Erlang is Elixir is a language.
yes. Elixir is a language, I'll make that clear. It runs on the Erlang VM. Why is it different than like some other concurrency things that you might like? Well, you know, like one thing going down is not going to cause the whole program to go down in any case, right? So this is, Go has some trouble with this. There's very, very lightweight threads that you make. They're not like system threads, they're its own kind of coroutines. So kind of like analogous to Go's threading. That's way, way more lightweight than what you get in like all these other languages, but of course, like we know there's like so many libraries that provide a similar thing in those languages. I forgot all of them, but you can Google it. So it's also sometimes really, really hard to kill the threads that you've started. Like in Go, it's impossible to do it reliably. In C++, C++11, it's also, I'm not aware of any way that you can kill a thread without like getting the native handle. And it's like, it's even like harder to see if they're alive and to like check if they started correctly and like monitor them without like some extra libraries on top. And
Clojure's threads are actually as lightweight and probably more lightweight than
Clojure's threads. Clojure also has some good threading. I don't know enough about it. Oh, and also another awesome part is that you can do live code reload. Your whole thing can be running, and you can reload parts of the code in real, like while all the other code that hasn't changed is running. So that's good for updating. You know, you could see how that's cool. Easy supervisors and less mutable state. We'll see. Okay, so it's got all the normal stuff. I won't go into it. If you're familiar with like functional languages, then yeah, we know what those are. If you're not, then like it's not interesting. This is the opinionated part on one side. Yeah, it's got all these things like meta programming.
Does it have macros?
Yeah, yes.
What kind of macros?
Oh, I that's a good question. I didn't read anything about macros. Anyway, so yeah, it's got this. That's not interesting. We're gonna get to the interesting part right now. No, we're not. So here's the syntax. It looks a lot like Ruby, and that's why I kept mentioning Ruby. Yes.
Yeah, like I heard they need Elixir because Erlang has this ancient syntax that has the most similarities with like Prolog.
That's true. Has anyone done Prolog here? Okay. Anyway, yeah. So like, you're exactly right. Erlang is like ancient syntax. Like people say that like syntax shouldn't be a deciding factor, but like, come on, we like things to look nice and modern subjectively. But Elixir also has the pipeline operator, so that's like a really important thing too. And obviously it has some other stuff, but like Erlang is really simple. It doesn't have like a lot of extra stuff tacked onto it in the standard library, and it's got like a Prolog syntax. For instance, to end a statement in Prolog, you would end it with a period, and I think the same thing is in Erlang. So it's like a lot like Ruby. It's weird. There's no currying that you'd get in Haskell. There's no separate arguments with a comma. Oh, sorry, my dad is calling. Yep. Cool. So if you like Ruby, which apparently no one does here, you're gonna love this. So, but the more interesting parts, the like concurrent parts. So, is anyone here like a Go person? I'm not actually, but Gopher. It's called a Gopher. This kind of sounds dumb. Whatever. Josh, you know Go.
Yeah? What about it?
That's it. So,
I know Go.
So
but
this-
was it a question?
No, it doesn't matter. There's nothing Elixir wants to do more than to run things at the same time. And so we have like a lot of these cool primitives that are really, really easy to use, and that are also kind of have good guarantees when you run them on the actual system. So here is like obviously this function ends like it ends after you spawn it. Erlang separates the idea of anonymous function from normal function, which is, you know, something that I don't really get. Basically, you spawn this. The function part is this entire thing, including the end, and then, you know, you're good. We're going to see in Go, if I guess no one's familiar, I'll use a different example. People know the actor model.
What? Oh, of actors?
Actors. So the thing is, like, a long time ago, there was this. Yeah, I'm going to use Brad Pitt as the name for the rest of the examples. So a long time ago, oh shit, I should. There was a decision that came down from the high temple of programming that said, you know, like if we try to do all these concurrent things and then we try to keep some state, have it all share some common state, it's really hard, and like things are gonna be shitty. It's just hard to debug. It's hard to mitigate against errors. It's hard to like keep things in sync. So the idea is instead of like keeping one thing that you share, you just send messages back and forth, and that's like the actor. Like each thread is its own thing, and it talks to other actors, and that's sending messages. And these messages normally would be like copied or somehow restricted against being mutated when you say them to another actor. So basically, if you have a lot of things just passing messages around, it's a lot easier to understand what's going on, and you get some nice things that if you put up the programming in the original state, you can see all the messages that went through, and then you can step by them and debug what happened. So now, yes. So another thing we do in Elixir is instead of like catching errors, we just let the thing crash. Because letting something crash at this point is really, really cheap. If all our threads are cheap, and like no thread can like cause an error with another thread if we don't want it to. So basically, if a bug happens, you're just going to let it fail, and like that's going to be the end of that. And it's great because, you know, like the best way to have long-running processes is to just restart them every once in a while. So this is kind of the same thing. So I say that like you can't have anything from other processes touch your process when that process kind of implodes, and that's true if you spawn it with spawn, and the other way to spawn things is spawn link, and that basically links your process to that process. So when an error happens in your process, an error will also happen. When an error happens in the process you spawned, an error will happen in yours. So you can see that like if you do a bunch of spawn links, you kind of end up establishing a tree where you know you will be some kind of process that is responsible for the children, et cetera, and this is morphs into, we'll see later, into like supervision trees where one thing is supervising the rest of these spawns, and it restarts them if they fail, and blah, blah, blah. And, you know, that kind of structure from like a lot of blog posts on the internet, apparently, it leads to some nicer, like more fault-tolerant systems, you know, if you can restart really fast and if everything is watching everything else. So that was processes, was normal spawn, and now we're going into the superset, which is tasks. And tasks are just like a nicer way of interacting with processes. They're one of like the big main things that come with Elixir that we're going to use when we're doing threading. And basically, you get all these like spawn and start link. Oh, okay, that first spawn should actually be start. You get start link and then async and await, which is like the like futures or whatever you want to call them that like we're used to. You like start something, and that's asynchronous. That goes in its own process. It computes something. The thread that's calling it, or the process that's calling it, it like halts for a while, and then when that finishes, it returns with a wait. And so like so the calling process gets stopped, so it doesn't take up a lot of CPU, and the the linked one actually does the work. So that's a nice way to handle stuff. And we're going to see these play out in what Josh has been asking for like a very, very long time. So get excited, Josh. Yeah, I made a thing, and you asked for it a while back, so it's kind of like it's your fault.
That doesn't sound like a good thing.
All right. Well, no, you don't. It's just
It's not yet.
whatever. It's not yet.
Oh, well, let me know when it.
Next. Oh wait, it is yet. A LUGatGT
Oh my God.
Elixir
Finally.
API.
You asked for an Elixir API.
You asked for
Elixir
something.
API.
So this is where the Ruby like fans would probably go crazy, but like I missed out on that today. But yeah, basically you have a module. There is functions. Def P is a private function, so you know. But basically, this is when you like have a bunch of concurrent programs that send messages to each other. You can think of like one program just maintaining some kind of state, and this is what this is doing. So let's oops. Okay.
Is it live?
What's live?
The Erlang Pizza module?
Oh, you'll never know. Does anyone know how do you check out to like the earliest, no. The earliest commit. Oh, I'm not even in what am I doing? This is a great opportunity to show you guys that all the presentation code is on GitHub. So you can follow along, or you can like read on it at the end. So
I think what you can do, I was going to say just put as many filters as possible because I think it'll just strip off extras.
really?
I'm not really sure.
Let's try that.
Never mind.
What? No.
Shell?
No.
You did check it out. Okay.
We're getting, man. Okay. What is this? No.
Tilda has an actual meaning.
What's above head? What's like
No, Tilda has
forward?
an actual meaning to it.
Yeah,
So, like,
yeah, I know, but I
If
figured
you
if
chain
you-
them, it's the equivalent.
Is it?
Yeah, I know, but I was thinking it was.
Is it +1? Okay.
It's like a carrot. You can just take it the child of a
6. Thank you. All right. So, okay, we're here.
Easy solution.
No.
Like, I heard an easy solution.
There's never an easy solution. Is it carrot to go forward?
Yeah.
Thank you. No.
You
Yeah.
probably need a.
No.
It's not head. It's a child's head. There's no
Thank
child's
you.
Head. It's like so. Carrot just gets you the commit child.
Oh,
If you have,
gosh.
If you have multiple. Oh, sorry.
No. That's not your fault.
Carrot's wrong.
That's it. I'm just gonna do that. Yeah. But some of these commits have like answers in them, which is why I don't want to. Okay, so IEX, that's the interpreter for Elixir. I'll make this a bit bigger so people can see it. Sorry. No, yeah, it is Elixir. You can compile things just like you did in Haskell, or in Haskell interpreter or whatever. Like this, bam, and we get pizza. So if we look back at our pizza code, we can see that basically we start it, and then we just start to link task, and it just, we loop,
Do you actually
here,
have an endpoint for this up already? 'Cause
and
everyone
then
knows
it goes to loop, and basically this receive call waits for messages from the channel, from send and receive, and it blocks for that, and then it matches, does some pattern matching, and says if I get a tuple, so things with braces are tuples here. If I get a tuple with the first thing having an atom of get, and the last thing is caller, I'm going to send them back, you know, if it's pizza day or not. So we'll try that out. Pizza.start, and we're going to get the PID of it. So each process and task makes a PID. So okay, we got a PID, and our PID is that. And we can send the PID.
And that process, that has no way corresponding to your actual OS's process set.
It does not. It is its own weird PID.
Okay.
So we can send a PID something like get what I have here. It searches for get and then like the caller. So you need to give your PID.
I think it's actually equivalent to like a queen thread, so it doesn't have a post-process ID.
Fuck, I forgot. Okay. Okay. So PID is like this. Fuck.
You have like a continuation there.
Yeah. So your own PID is with self. Okay, wants me to use parentheses. And then we're gonna, doesn't have the history. So we will start it with start. And then basically we'll send get and self to the PID. No, I want this. Cool. Okay. So now we don't have something set up for our receive hook, so we're going to call flush, and we get true. And flush just, you know, it puts out everything in our like message buffer. So here it is actually pizza day. That's awesome. So you can see how like this thing kind of is actually just some global state that you can call on at any time and get some kind of information. So that kind of thing is called an agent in Elixir, and like it's kind of the point where things stop becoming immutable. If you think of mutability that way. Okay. Now mix the Elixir like build toolchain is a lot like cargo or I don't know, what's another one? What? Pip, npm. It like makes you a project and it like gets dependencies and it does all the like weird stuff. So here's what you get when you get a full when you do just a new blank thing with this command. You get a README, which is interesting. You get, which is actually the same README as is in here, which is kind of cool. You know, it's like almost pretty close. Cool. And pro tip time: Laravel has their own version of Elixir and Mix, which is some like build system that they wrote in JavaScript. It like comes up in search results. I don't know why like they named it that, but like they kind of named it the same thing as these things. What? That's a good question. But I don't like Laravel, so I'm going to say that Elixir came first. I'm not a web artisan, and so it doesn't speak to like what. Yeah. So many opinions about Laravel. But yeah, pro tip. Cool. So another thing, OTP. It's the Open Telecom platform. It's the thing that Ericsson made a long time ago. Comes with Erlang and it comes with Elixir 2. It has all of these cool fault-tolerant things like supervisors, blah blah blah, all those things that I've been talking about. So
how did that relate at all?
this is there's a line in there that says, "Are you down with OPP?" Which, yeah, that's it. Okay. No, other people's property. No. I'm just embarrassing myself. Demo time. right? We're doing it live. We still don't know how to like freaking do the whatever. Okay. Let's add a TCP server. Cool. That was easy. So here's our server. Nope. So we changed pizza. God damn it. So we changed pizza to just do this because we're gonna do the actual server somewhere else in TCP server. It's still just like calculates when it's pizza. There's a magic number here that's set to somehow end after like sometime around now. So we'll see how far that gets us. And then I don't know why this happens, but whatever. More importantly, here's our server. So you can kind of see like it looks pretty close to like some kind of imperative thing that you might come across. And so I think like if you are new to functional programming, actually, this is a wonderful language to learn, especially if you're new to concurrent actor model programming. This is like pretty good because it looks really familiar and things kind of like the pipeline operator, when you use it, it kind of makes things go sequentially like you're used to and not recursively. So the first thing is, just a bunch of options. I won't go through them all. Basically, if you're not familiar with pattern matching, this listen returns back a tuple that has an atom in it and another variable value in it. And basically, this pattern says I want to match against that. Basically, I want to take the second element of that tuple and call it socket and then use it in other places. And I want to check that the first element is actually okay. Cool. So now we go to, and basically you just loop. You get a client, you read a line, that's the protocol, and then you return some JSON, is it pizza or not? And that's pretty simple. So so does this work? You can run it in your, yeah.
Is it TCP or is it HTTP?
This is TCP.
So if I just like things or
So we're gonna go on 8080. It's gonna start, and now we can netcat, if you guys aren't familiar. Netcat to localhost 8080, and then you can say, "Is it pizza?" If pizza is true.
There's something cool I want to show you. So
What?
instead of using netcat,
Yeah.
you can just use the native dash TCP interface.
What?
So you can echo. So like in a new terminal.
Okay, wait. Later.
Do like.
Later, Colin.
Okay.
Okay, so this is actually just wants new lines, so you can give it as many new lines as possible, and it'll give us true. Awesome. What happens if we close the connection? Control D. Yeah, right. That should do it. Nope. Whatever. Control C. We get an error, and our whole thing crashes, and that sucks. Like our entire server crashed just because one guy disconnected, and that's happening because this had error closed. So we got like a closed signal from our connection, and that's God damn it, server. No, yeah. No, now it has the heuristic that I clicked that a lot. Okay. So basically, here's what it's doing. It's expecting OK client, but it actually got the error atom instead. So it's crashing. So how are we gonna fix that? Well, from what you guys know about Elixir, what do you guys think we're gonna do? Like, yes? That's a good idea, but no. No, we're not gonna do that.
This is about Gordon. I feel like you're gonna. This is where that type thing comes in.
Mhm.
About
Maybe.
I don't know what the
Okay. I know. I could do anything. But
You switch languages.
we're gonna switch.
Yeah, this is where you switch to Rust.
Yeah, no, we're just gonna, yeah, we're gonna keep on Rust. So the answer is fail fast, right? It's not catch the error and then just restart it. And that's pretty good. I agree, if that's the philosophy. Because like the client has closed the connection anyway, and we don't need it. It crashes, it fails, and we restart another one when another connection happens. So, well, like the way is that like you can't be trusted to write good exception handling, so we're just gonna crash it.
So wouldn't that like?
So.
Wouldn't that potentially waste like TCP resources?
No.
Right? Because you're
I don't know.
crashing, so that
The Erlang VM is still going to.
it's going to clean up
read
those resources.
Yeah, it doesn't. Its crash is very clean. It really.
Sometimes it never works and you just get infinite loop.
That's right.
It's
So.
really crappy when you should do that.
Yeah, I mean, one, you're crap code. I'm kidding. The other one is depending, there's a lot of strategies on how to handle these processes, and depending on the one you pick, other policies will be taken in place. Like the default one is, I think, it can't restart more than like n times and n seconds, something like that. But we're not going to run into this. So the big, okay. So the question is, but is it 10x upscale? And I already answered that. So it was no. So like supervisors. This is what supervisors do. Pretty good. Basically, it's really easy to see. You make this supervisor. You assign it a worker, and the worker is of type task, and it calls this module, this method, and this argument to it. So that's like what's going on there, and you start. This is the strategy 1 for 1, and that means if this thing dies, restart it and keep one thing happening, running at all times, hopefully. And then you name your supervisor to keep track of it for debugging.
Is there a way to not? Can you just not name it, or is that required? If you want to like spin up.
I don't think it's required. I don't think it's required. So we'll see. Let's see how this goes. We're going to go to here. I guess.
Really, there's no point in doing branches if you're coding.
Did you just say there's no point in
If
doing
you're,
branches there?
if you're coding linear like progress by yourself.
You have to have a branch for every commit. In fact, just each branch.
So when you're doing something with mix, you're gonna like go get this mix file, which just gives you like a bunch of metadata. Basically, you put in your main module over here. It's all on GitHub, and then you make a main module over here. So our module has to be outside of the server because it's going to supervise the server naturally. So I made this main module, and we can see that like this thing accepts 8080, keep it 1 for 1, and start it. We can run it with always run it like this, and see we are accepting connections and starting the app. We have, which is this logger thing. So another interesting point is that the logger isn't actually like doing any I/O on the actual process that you're on. It's its own process that gets started up as your logger process, and you send it messages.
Can you replace the logger process with a customer?
Yeah. But like logger is not a special name, so you can just use a different module. Yeah. And that's kind of handy. Basically, you get this like weird cluster of things that all talk to each other. And we can see, let's see. Okay, things are working so far, pretty good. Now, I close the connection. Cool. Okay. And, okay, well, you guys don't know that it's cool yet, but I know that it's cool. Let's try it again.
Are we like going, are you
Yeah.
actually going to like run this as a LUGatGT service? Because I want to write like 10 or 15 bots to keep off this.
We're gonna get there. We're gonna make it all the way to web scale in an hour. It's gonna be cool. So we closed it. Yep. Okay, still running. Everything's still good. Now, fuck. Okay, whatever. You saw that. So does anyone know what's wrong with this line of code? We have another scaling issue that we got to fix. I'll walk you through it. Yes.
Is serve blocking?
Serve is defined at def serve.
So can we serve multiple people?
No, we can't. Great point. If you don't see it, serve is called here. You write some stuff. You read from the socket, which is blocking, and then you write, which is also blocking. But and you call serve again. So this becomes a loop, and it loops forever. And this next loop acceptor thing is never called. So what are we going to do in Elixir?
Lots of callbacks.
Just lots of callbacks is incorrect. We're not in Node. It's another guess. It's really easy.
Just do something that makes it non-block.
Yeah, just start another process. Like you always just start another process, and like that's your solution for 80-90% of problems. Cool. So let's triple check that we have that. Okay, this works, but then let's see that if I do this, it doesn't work anymore. Damn. Okay. And there's no new errors because it never got to accepting that client in the first place. So, what's the next slide? I don't know. Yep. Okay.
Quick question.
Yes.
So one of the features, you might not be able to, so one of the features you talked about though is being able to live reload code while it's still running.
Mm-hmm.
You can do that for like the next fix.
We're gonna get there. Actually, I can. We can do that now if you want. Let's see.
Did you already have like an example set up for this thing?
No, this is. Oh, it's not in the. It's not in the source. Let's do it later. But yeah, you can live reload code, which is super helpful. You can also. There's a GUI that pops up that shows you all the processes and how they're connected, which is kind of cool, but it's kind of like a weird thing to be included. The GUI is not web scale. It's a GUI. It would be web scale if it was a browser endpoint. Okay, where is it? This? Nope. Can't listen to many clients. That sounds like what we want. Yes. Okay. So let's see what changed. So the first thing is here. Actually, it'll be probably easier if easier to see if I just go in here and deal with it. Okay. So this thing gets added. Basically, now our supervisor has a supervisor as a child and then has a worker. If you want to look at this as a supervision tree, it would be a supervisor can have a supervisor or leaf nodes, leaves. And in this case, the worker is a leaf and the supervisor is yet another supervisor. So this is the big one, and it controls another one, which controls another one. And the other thing I have is the server, which needs changing a little bit. And this is a really, you probably expected this change. Basically, you just use the supervisor, task.supervisor to start the child, and you give it some function, which is serve. Get the PID, and then the final important thing is to move the responsibility of closing the socket to the correct PID, and that's the this line controlling process. So pretty good. Let's see how this goes. So we're gonna run it again. Okay, this is true. Oops. This is true too. Awesome. So 2 apps 2 connections at the same time. It's almost 100,000, which is like that challenge that people like to do. So yeah, 2 simultaneous connections, and honestly, the code has been pretty simple so far. The supervisor thing is kind of hard to get your head around for a little bit, but yeah. The reason we didn't have to do any kind of strategy for task.supervisor or something is because doing these things where you start a task and you just like wait for it to, you want to know what happens to it, but like you don't really care about anything else, is a really common pattern, and they've just included the boilerplate for you in the task.supervisor module. So that's why it's different. So, but right, can we scale it further? So let's go to AWS where all the scaling happens. All the
AWS web scale?
it's all the scale fairies or in. Do I need? No, I'm not gonna get updates. Come on. Okay, here's our sample elixir. Oh my gosh. This is really happening. Oops. Yeah, so obviously you run production things in screen because if you close it as SSH, you'll just like exit. What are you gonna do?
It's like
What are you gonna do?
so you can run it as like no HF.
No, I know there's so many ways, but like we're gonna stick with this. Pizza, cool. So now we're gonna do. Yes, this is the command I was looking for. So you can run things with IEX, which is the interpreter, which lets you interpret things. You can also just run things straight, which is mix, run, and no halt. So it's just not going to stop for anyone. So let's see. Yep, starts up, does everything we want. Let's see. Let's see what our public IP is. Is this one? No, that's not it. I don't remember. It's in this though. Great. Shit. 35.165.21.192. 192.88. And is it pizza? Yes, nice. So I have this one instance for a year for free. You can get all of these instances. You can get their like second to smallest instance for free for a year. So this will be up for I guess a year, and I guess other things. Actually, maybe I'll ask Ryan to put it on his server. Josh,
What?
this IP.
What? Oh shit! Is it public now?
Yeah.
Somebody send that onto XMPP.
Also, side note, Google Summer of Code is out. You guys should do it if you got free time in the summer. You contribute to open source projects and they pay you $5,000. It's kind of cool. A cool, people, companies and projects have to apply to be part of it. This year, Conversations, the XMPP client is part of it. And Mozilla is part of it. There's some cool ones. Clojure is also part of it. Josh, wink.
Andrew's been part of it a couple of years.
Who?
Like Google Summer Code.
There's a bunch of
Ginger?
fancy shit.
Yeah, there's a lot of different random.
Yeah, there's so many. Okay, so.
Like Ryan's machine learning library thing.
Oh, really?
Was
That's awesome.
part of it one year.
Okay, we are going to. Cool. So I'm going to exit out of this. I'm going to show you some live reloading. It's going to be really cool. So here is my notes for reloading code. But basically, this is just for reloading it in the REPL. There's more automated ways to do it later. So you'd run this, I think. Yes. Run. So basically, when you run, damn it. Ooh. Okay, so when you run this, it kind of starts your things up automatically. If you don't want to do that, you pass in no start, and let's just do that. So much easier. I'm gonna shrink this so you guys can't read it, and I still look prepared. Okay. So we're going to basically get the PID of our main program like this. Main.start we defined a while ago, and there's 2 arguments it takes as part of the API for the start function of any thing. I'm pretty sure it's probably args, but like whatever. You get the PID. Oh my god. Oh, things in use. Okay. So yeah, we're already running it here, so let's exit out of that and do this. Cool. So start it. Cool. Things started. We're gonna see what happens. So this is true. Okay, it's true for now. Now we're going to suspend it, basically. And this will temporarily halt it. We'll go and edit something. I don't know what you guys.
Make it false instead of true.
Yeah. So, god damn it. Okay. I changed that to 0 if no one could see. Basically just mods by 2 and checks. So I changed to the other one. Hopefully it'll be false. And you compile it again. Pretty cool. And then you do this sys.change code, which is pretty scary. You give it a PID number, the module, same class that you wanna change the code of. You give it the string that no one really knows what it is. You give it the method that you want to change, which we changed this method, and it reloads. Pretty good. And you can do sys.resume PID. Okay.
After making that change, when you suspend the process, does it keep all the same memory stuff of the process? Like, do the contents of the memory change of the process after you eliminate it? Does it just restart it?
The point is that I think the answer is it just redoes the things that what you give it here in the method, like this method. But I also don't know. So let's see. False. Nice. Pretty good. Pretty good. So you can suspend the main PID, which is kind of like restarting it, but you can also suspend any other PID you want, and you can tweak things in that process, and then actually it probably makes sense if it restarts just the process that you called. So yeah, you can pick off PIDs and restart them and stuff like that. Okay. Finally, I think that's. I'll show the Elixir website. So this thing is made to handle just tons of connections. It's supposed to be very efficient, and we wrote something kind of very, very efficient, very quickly. So if you want something, if that sounds attractive to you, maybe you'll pick this for your next project. Here is the free guide. It's pretty okay. There's one part where they tell you about the GUI. Yeah, here we go. Okay. So this observer.start thing. Never actually tried this. So let's go. Nope. WXC.
It's called that WXT, not WXT, but
Okay.
WX.
Installing something on Linux live.
Are you on LinkedIn?
The worst possible thing ever. Is that like a package?
It's just a GUI framework. It's like
It's used by
GTK. Just search like WX.
Every time I look at something that needs WX widgets, it is always the thing that is broken. I can never get WX
Maybe this isn't.
widgets.
Oh wait, I'm on Arch. Goddamn.
What?
I'm on, yeah. WXGTK. See, that was so easy, I guess.
Why wouldn't you just Pac-Man search it?
Because this is faster, Colin. It's more user-friendly. Reinstalling, damn it. Nothing. Actually, I guess you can look at the optional dependencies and see what it wants. Are they? Thank you for that. It might be Python's Wix.
No, it's for a shared object.
Oh yeah, you're right. Okay, well, sorry guys. That's what happens when you don't prepare your thing. But yeah. WXE driver.
Pac-Man search.
just like, oh man, forums. Oh man. Yeah, I'm not gonna do this, guys. I'll let you go. So, thank you all for learning about this weird thing. And, you know, I hope like this makes it a little bit easier for you guys to either enter into some functional programming or to like build some really, really concurrent apps in a language other than Go or some other thing
And
that
run MongoDB.
is worse.
Can it lose all of my data if there's a network cut?
I mean, probably it could. I mean, you could do it. Yeah, like if you lose your network, like Elixir actually runs on the cloud. What I've been doing here is connects to a cloud service that runs Elixir. It's fully proprietary.
Is that AWS thing that you're doing?
Is that a joke or not?
Is that charged by like? How does charging for that work? Like,
Charging?
Like-
Oh, for AWS? AWS is the most complicated thing I've ever seen.
does it like
in my
cost
life.
more money? Like more like little bit? Like it's like they nickel and dime you.
So like there's a lot of options. You basically pay for things and then you independently of that start instances and then you use some of that payment.
Just pay all of your money up front.
Yeah, like so basically I got the free tier and I set up an alert to email me when I spend $1. So we'll see how that goes. But I'm sure
Like spending the $500 all at once.
See, someone needs to set up like a stock bot that automatically, that all it does is make enough money in the stock market to pay for itself on AWS.
Oh yeah, okay.
And it
Josh.
It runs itself on that AWS
Yeah, so
server.
it can make enough.
Josh, here's the IP. Oh yeah, everyone else, here's the IP. Go check that if you
Permanently running service.
if you want an API.
I am going to add a widget to my desktop now.
Okay, live stream's over. See you guys.